Hi, my name's Andrew McLaren, and I want to help you with solving challenging rate law problems where they've kind of changed a few things on you and they're not constant in different trials, so it's more challenging. So this, you kind of start in a similar way to how you would normally, but the trick really is to use some estimation. I have a whole video where I calculate like the specific number, but using estimation makes this like way, way quicker. So if we're just looking at this problem right here, they usually will give you some case where something is held constant and you can see the change and its impact on the rate. So here, if I've doubled up the concentration, it looks like I've doubled up the rate. So in our terms of our rate law, you've got the K and then you've got our two different variables and they're going up to some sort of power. For the HB, we can look and see just from this piece that this has to be up to the first power. Because if I times this by 2, this is also times by 2. Relatively easy, that first part. Now, if we're talking about the second part, what you can do is a little bit of guess and check. You can say, is this maybe up to the 0 power? Would that possibly be something that could explain what we're seeing here? Now, it doesn't, because if we're looking at this problem going from this trial, like comparing 2 to 3, you can see how things are impacted. If we are looking at the HB, it looks like the change is that it goes down like 75%. And that is not the case with the rate law. It looks like it's going up by like about 50%. Like 2 times overall. So whatever this is, it can't be up to the 0 power. No. So then you could ask yourself, like, what if I were to put up the first power, or if I put up the second power? Could that explain this? I'm seeing that if we were to maybe try doing this up to the second power, that would be like, this is 2.4x. 2.4x, if you square that, that's going to be a pretty big factor. I'm not sure if that is the case. I think it actually would be up to the first power. That would be more appropriate to think about it like that. But we've got like 2.4, and you can square that, and that's going to be like 5.7. X squared, and that seems to me like that is a little bit too big. So we can then ask, like, well, what if we do that first power? And it looks like that 2.4 up to that first power times that 0.75. I mean, it's coming about 2-ish. I'm definitely doing some big estimations there, but it looks to me like when we have like 2.4 up to that first power, and we have the like 0.75 up to that first power, and we multiply those out, we're getting a rate change that is about what we want. So this is a very quick and easy way of going through these problems, just using a little estimation. Be like, does 0 work here? Does 1 work here? Does 2 work here? And would that math out correctly as an appropriate change? Thank you for McLearning with me. Before you go, please check out the following services that I offer with my business. So if you click the link in my videos, this goes to my website. I might be changing it from Podia because I'm no longer doing the interactive videos for sale. I might put those up for free. But most of my other services are linked here. So you can see that I've got like a Teachers Pay Teachers and a Wyzant. The Teachers Pay Teachers has a lot of my assessments that I have for like the NGSS, as well as lessons that I made when I was actually a teacher in the classroom. So I've got quite a few things like CERs and other things on there. If you want to get one-on-one live support from me, either like with science or like working on like teaching support lessons and that kind of stuff, you can sign up through Wyzant. I have a link to there where you can contact me there, and we can schedule hourly appointments. And I've got a few other things on here, like a Facebook page, and our social media. And if you're interested in getting professional development with me for like a team of teachers, a whole page with information on that. So yeah, feel free to check that out. Thank you.